He's a great speaker. He's someone of talent. We're a bit short on time, so please excuse him if he's a bit rushed. But I'm sure you will love what he has to say. Please welcome Jaime Sanchez. Good luck.
Okay. Hi everyone, sorry for the delay. My first recommendation will be do not throw your computer to the floor 5 seconds before your talk. And well, this is a research that I have made with another mate. Some of you knows me from the last year. I spoke about some kernel module called IPQ and about the remote fingerprinting and so. And since then I have spoken in so many conferences, DEFCON, Black Hat, a lot of them. My mate, it's Pablo. He couldn't travel here, but he's almost an experienced researcher, and this is done by him too. So we will start talking about instant messaging. We put the focus of our research in this because it's almost used by the early adopters, people that are below 25 years. And the instant messaging business is growing. You know, it has been like WhatsApp and that kind of programs have done to the SMS, the same that did Skype to the landlines. And there are some facts. It's that, as we said, almost all the instant messaging are driven by teens. The graph in the instant messaging is very close. It's not the same as in Facebook. And there have been a lot of security issues that made this relevant. You see, here we have a map with almost the top application for instant messaging. The most known right now are WhatsApp, Line. You have two Facebook Messenger. But the thing is that is our communication secure when we are using those kinds of applications? Does the vendor use all the resources to do secure communications? The answer is that most of them aren't very secure. There are identity thieves. They almost then have lack of encryption. There are a lot of spam. And we have put the focus in our research in 3 of these applications that are Snapchat, Viber, and the main focus goes to WhatsApp. So I start with the travel with Snapchat. If you don't know Snapchat, it's a mobile application you can download that is available to iPhones and Android. And the funny thing is that you can send all kinds of pictures and you can put a timer and the photo or the video gets deleted after. The main problem with this is that, I don't know here in France, but most in Europe, there aren't many people using it, but in the United States, there are almost like 100 million of users. There are 400 million snaps per day that are sent and received. And well, in Norway and the UK, there are a lot of users. But most of them are in the United States, where some other programs, like WhatsApp, doesn't have the same number of users. But let's be real. The thing about Snapchat is not only about sending text or chat with your companions. It's only used for sexting. So there is a big problem with this because there are some things we need to know after begin sending these kind of pictures to our friends. If you think that the main thing that Snapchat has to do, that is deleting the photographs after it comes to your mobile phone, you may be wrong, because there are proofs that you can recover all the images that you get into your phone, and you can do all kinds of forensics to recover it, because they are not erased it. Snapchat has, some months ago, a big problem because some researcher advised them about a vulnerability that they can use to get almost all the database of users they have only by searching by the number. They didn't care at all, and they get like published 4 million user database. So we decide to begin exploring. This is, I don't know if you can see, but this is the method that uses Snapchat to send the snaps. There are only two. It's upload and send to functions, and one that is both of them that it's retry. In retry, you can use your username and you can use your token to send all the images. So the first thing we started to do is trying to remove the username and trying to impersonate another. But we have to make something about the token. So what we first done was removing the token, and let's see what happened. We thought that we could send message to everyone, but you have to be friend of the other person so they can receive it. So we thought about what account was friend of almost every user. So we tried with a very special that it was Team Snapchat, and the result were something like this. I don't know if you can see the Burp screen, but you can see in my iPhone that all the snaps are received from Team Snapchat. So this was the first fail. But when we were working, we were doing the research, we were doing sign slides for our conference, they noticed that maybe the token and the username were something that they should take care. So almost 6 days after, they solved it. And then they screw up our research for SmookOn, and we have to try harder. So if we cannot send snaps with any other username, what can we do? Well, maybe what we can do is do spam. We have the database with 4 million usernames, and let's try if we can send all the snaps we want by using only the same request token. At first, what we try is using the request token. It was like, you can see it, but it was like a 14th of January, and almost a week after, the same request token that was created for every snap you sent was still useful. So what we do is, instead of putting the terminal with our Python script, we capture a single query to the Snapchat server. And we begin inserting the database. You can see that there are some forms. You need to modify only the field of the people you want to receive the token. And as you can see, it will begin. And it can be as fast as almost 1,000 snaps per minute. In this case, you're going to see that it can update, but you can spam all the database of Snapchat users. The other thing we discovered that gets published in the Los Angeles Times is that if we are able to send all the snaps we want, almost 1,000 per minute, we can make the iPhone crash. It will crash, and it won't be able to recover from the attack until you have finished sending the snaps or until you deactivate all the data. And the first countermeasure that they take was banning our account. After some emails that we changed, they told us that they have put some focus on the problem and that this problem is almost solved in the last version. So we take the challenge and think about another thing. Is instead of using one computer, we are using a distributed attack to send all the snaps. I will be publishing this script because we are really tired of speaking to the security team of Snapchat, and they are almost not answering. But the thing is, if they had put a limit, you can bypass it by using several servers. The only thing you have to do is changing the media ID that it's inside almost every query of Snapchat, and enjoy. Any phone running iOS, if you are able to send all the snaps required, you could be crashing it. Now, let's go to where is the problem. The problem is almost in the Apple Post notification system, because as Snapchat are sending the snaps to the client, they are throwing it through a buffer that it should connect to the Apple servers and so. But the main problem is that you can overflow all that buffer and your phone won't be able to analyze all the messages that they are receiving. In this time, Apple is still researching this kind of problem, and I'm sure that they will solve it nearly. So when we finished with Snapchat, we put the focus on Beaver. Beaver was a cool application that was used by many people like years ago. Now I think that they have no more users. But the thing is that they are saying that their systems are very secure, but what they don't tell you is that almost every message, almost every photo, almost every video, your location are sent with a HTTP. So anyone that is doing a man in the middle with a rogue app can view your message, can view your pictures, can view your location, and so. And the last one, and the most important for us, was WhatsApp. Let me drink a little bit. Please don't eat a spicy sandwich before a talk. It's horrible. Yeah, you are laughing. Yeah, I know you. Well, WhatsApp is the most important program that we have almost in every country. It has almost 500 million of users. It's been used in Brazil, South Africa, in Spain, in Europe. And there are more than 10 billion messages sent and received per day. This is interesting because compared to Twitter, Twitter has only 200 million users, and Instagram 150 users active day by day. So how much is 10 billion messages? It's like 400 million messages an hour, almost 7 million messages a minute, and almost 100,000 messages a second. So they have done to the SMS, as we said before, the same that Skype did to the conventional landlines. You know that Facebook acquires it for a lot of money, but you know that there are something that never change. After this announcement, WhatsApp goes down like 3 days with no service, and everyone starts complaining. But the thing about the Facebook and WhatsApp is because Facebook hasn't been able to convert all the mobile users to use Facebook Messenger, to use the conventional platform, and if you can beat your enemy, maybe you can just buy them. This is a graphical of the growth of WhatsApp for 4 years. You can see that it's almost 4 times what Facebook did, that get only 145 million of users, and it became the history with security flaws. At first time, all the communications within WhatsApp begin like with no encryption, so you could just launch a sniffer, launch Wireshark, wherever you want, and you could get all the communications. Then they realized that they didn't need security and began using only the email or your MAC address of your computer to encrypt all your data. But then we began researching, and we saw that we could remotely upload malware to the WhatsApp servers. All the data in the database is plain text. There is no encryption. You could change the status. There has been like a worm for that we know that it's called Priyanka. There was another program that could let you see all the pictures of the registered users without being in the service. And there is no authorization, there is no test. No one will look at your message, so you can begin your own botnet. You can begin spamming all your clients. And last version of WhatsApp has a flow that allows people to decrypt the message. These are some kind of other malware and ransomware that were affecting WhatsApp. There is some spying programs that let you read the database and so. And then we have an idea. The main part of the idea was to have any layer with privacy and encryption and security that will guarantee us that we would have no problems with this kind of encryption. So we create a program with has 3 layers. The one is about secure encryption. We have discovered that WhatsApp isn't using a secure encryption algorithm, so we are implementing our own. The second one is giving anonymity using hops inside the Tor network. And the last one was using our own XMPP server, so we don't need the official WhatsApp server anymore. But why? Because the NSA seems to be the only part of the government that actually is listening to the people. So we begin thinking if Snowden and all the documents they reveal about PRISM and so, that includes Microsoft, includes Gmail, Google, Skype, Apple, Dropbox, Yahoo. Maybe these are very important companies for the NSA to get all the information and all the documents. Maybe the instant messaging protocols like WhatsApp could be interesting for them. And then we get to a very important part that was the SMS surveillance, that it was from 2011. And they say that they were extracting like 5 million missed call alerts by a day, 1 million border crossings a day, 100,000 names, financial transactions, everything. So maybe the instant messaging protocols are the next target. So let me explain what we have done to WhatsApp, but at first we have to know how does WhatsApp works from the inside. As we said, this is the password evolution. I will not explain what is some plain text encryption. In this case, this is the second chance they took. They used like using an MD5 from your email or your MAC address. You could just install a sniffer or a rogue app, and you just take all the data, and you could be impersonating all the people in the same network. You can just have the phone number that is important to register the account, but you can get all the information. When you look into the device, you know that it's something simple. You can get your phone, put your phone number, it connects to the WhatsApp server, and you get a number in an SMS that you can put it to close the challenge. But inside, there is an SASL mechanism. It's called WhatsApp Authentication. In this case, it's WhatsApp Authentication 1, because we will see that they have done another version. And it will generate some kind of challenge with PKBDF2 using SH1, and they take 20 bytes, and it begins like encrypting all the conversation. You can see in this slide, this is part of the process. This is the first packet that the WhatsApp is sending. But the important thing is that there has been some difference. In the last version of WhatsApp, that it was dated last year, all the passwords were the same. They were using RC4, so you were sending message and you were receiving message using the same password. For HMAC, they were using all the bytes, and as we have seen, they were using 16 times PKBDF2, and this is the capture of the initial handshake. So we went to the WhatsApp website to see if our messages were secure, and they say something like, WhatsApp communication between your phone and our server is fully encrypted. Fully encrypted using RC4. I think that you know all the problems that have RC4, and apart of all the problems that you can have if you don't implement it the right way. So, for common people, where is the problem? Let's use an example that Alice encrypts a message that wants to send to Bob using a public channel, and they are using a shared key that they have decided. So, because Alice is extraordinarily lazy, they use the same password for sending and receiving all the conversation. So when if intercept both of them, they can use an XOR of the ciphertext and erase the part of the key. I don't know why, but every time Alice encrypts a message, God kill a kitten. So when you attack the encryption, you have to do some kind of plain text attack. It's called crypt dragging. You have to know where the offsets of the message are, but you can know it because when you are doing the XOR operation between the packets, you can know some kind of packets that are inside of the private words of WhatsApp. So you only have to do the XOR, trying to know where is a combination of keys until you get a result. It's almost done using frequency analysis. It depends on the language you are using. But the important thing is what they took, all the attitude they took about this. They told people that while they appreciate the feedback, they were concerned about what the scenario, and it's more theoretical in nature. So what we done, that you can almost download in the future, is doing a Python script that it's doing all the crypt dragging process more interactively. So if you know all the offsets that it's beginning inside every message of WhatsApp, you can put it on the same row and trying to look for the combination of the letters to decrypt the message. The hard part is only the first 3 or 2 characters. The next time you are almost trying to seek a message that has any sense. Then WhatsApp, despite saying that it was only a theoretical problem, came with another version of the authentication that is called WhatsApp 2. In this case, all the passwords are different. So when you send a message and when you receive a message, all the passwords are different. Almost they are using RC4. They are putting some kind of focus on the HMAC for the verification, and they are adding to the message some bytes at the end that are indicating the number of messages that you are sending. So if you are sending the third message, apart from the HMAC, they will put the byte in X 03. And in this case, they are using the same mechanism for building the passwords. So the only thing they are adding is that there are 4 passwords, and at the first password they add the byte 1, at the password 2, the byte 2, and so. So we started to make some experiments. I don't know if we can see this. Well, it was a proof of concept that we launched in SmoothCon. So we haven't been able to do it again because we changed our version on the phone. But if you know, if you see, you can see you can send a message to the client. It will receive. It would show it. But there is some kind of problem with WhatsApp with older versions that it cannot read the unprintable characters. So it will crash almost every time. It cannot print any character. This isn't a big issue because we haven't found any way to exploit this or make it vulnerable. But there are some other things that we can use. That is, for example, we can impersonate other person, but not sending the message, but just by receiving. I know that people may think that this is not important because you can only put the fake number on your phone, but you have to think about the legal implication of this. With this, what you can do is have a message sent to your phone with your database correct, all the forensic will be correct, and maybe put a demand because someone is reading you. And when they do the forensics to your phone, everything is okay. On the WhatsApp servers, there is no message, and on the other phone, they can be erased. So in Spain, for example, that's the case we know, these kind of proofs have been accepted from the judge, so it can have legal implications for other person. What we try to do is add some kind of encryption. So in the first case, we use symmetric encryption. What we are doing is taking the message after it leaves our phones. We try to disassemble it. We take the text, we encrypt with our algorithm, and we send it to the WhatsApp server. So when it gets to the other phone, it takes the same mechanism in the other way. It breaks the WhatsApp protocol, it decrypts the packet with our private key, and then get into the other phone as nothing happens. The only thing that we have to know is that in every authentication with WhatsApp, all the keys should be negotiated at first time, but this doesn't happen on iOS because they put the challenge for this session and then save the challenge for the next one. So what we have to do is at first flip some bytes and force to begin the authentication again to capture all the traffic. These are some slides where you can see all the text. I know that they are far along from where you are, so we can go to the video. And in this case, we are going to see what we have spoken about. We have all our proxy. We have launched a VPN. This is data from the WhatsApp. And in this case, if you can see the pink characters, is that we have flipped all the bytes in the negotiation. So we are forcing both of WhatsApp servers on the terminal to get the new ones. When we found the challenge, we are able to decrypt all the WhatsApp protocol. So we need another phone to enter and have it the same way. In this time, it's going to enter through the VPN. And if you see, you have the other one. This is the challenge from the other number. So we can control from the two sides all the communications from WhatsApp. And what we are going to do is send some kind of example message. You can see is here. What? Is here. This is the server payload. This is where our server are sending to us. And we will take all the information from heap and take the number and only change these characters that are the ones that are going to be ciphered in the future. This is when the message is sent. And when we answer to the other side, we will have the same. Okay. We're taking the same message, the AC key, and we are taking only the text, ciphering with our private password, and then let it go to the server. So, without the private key, almost you are able to break the RC4 encryption, or you can do a man in the middle wherever you want. This is the only thing that we are going to see. The next thing that we tried was anonymity. In this case, we haven't shown the proof of concept, but it's only using Yusuf. That's it's a client that it's available for a terminal for WhatsApp. And what we can do is trying to put some kind of hops between the members of the conversation, so they can redirect all the message from one side to other side. And with this kind of things, you can put it harder for people to investigate or get the metadata of the conversation of whatever we want. But the last thing that is almost the most important was using an external server, because we know that we have been using RC4 with WhatsApp. You know that you can implement your own algorithm, but if someone maybe wants to spy on you, maybe they will. So the only thing to do is trying to use another server that is different from the original. So what we've done is modify the XMPP server, and when we are listening to the conversation between the two clients, we are taking only the destination number, the message ID, and the original text. And what we are going to do is taking the text apart, send it through our server, let only the communication pass between WhatsApp sender and the receiver with no data, or maybe a wild character. In this case, we are using the same. We are using a VPN. We need to do to find the challenge first. You see, it's there. And there will be another phone that should enter right now. And it is sending a message. If you can see, this is the payload of the conversation. What we are going to do is take all the message length. In this case, to see that it's working, we translate with the letter G all the message. That this is the part of the message that will go through WhatsApp. And then the other part is going through a private XMPP server. You have seen that we have received our message, like nothing is happening. And just to be sure, we're going to take another test that you can answer to your mate through the same way. everything is working okay. We are using another XMPP server to set the info, but if you see, if we disconnect the VPN and we try to receive a message, what we would get is the well character. So WhatsApp can only see this if you want, or nothing if you want us to send a black message, and this is what the NSA can see. And with this, it's almost done. Thank you.